Hi, I'm Martin Swetman, and in this video I'm going to continue my review of the Younger Dryas impact debate research. Now, so far we've covered the published research from the original Firestone paper in 2007 through to early 2014 in the last video. So in this video I'm going to continue reviewing papers from 2014. Now remember where we got to last time. Geochemical evidence for the Younger Dryas impact around 12,800 years ago has been found across the North American continent and into Western Europe and even into the Near East by the Comet Research Group and reproduced by other independent research groups. And specifically, they have found nanodiamonds, iridium-rich magnetic grains, and impact-generated spherules at the base of the Younger Dryas black mat. Now, crucially, a platinum spike has also been found in Greenland ice, and it dates to within a few years of the onset of the Younger Dryas cooling, indicating very strongly that a cosmic impact caused the cooling. More nanodiamonds and evidence of wildfires at around the same time horizon have also been found in the Greenland ice, although those results have not yet been reproduced by other groups. And it's important to note, though, that the review paper by Van Hussel et al. That we looked at in the last video shows that only around 7 or 8 of the various black mat sites, and there are about 20 of them or more, so only about 7 or 8 of them can be accurately and precisely dated to the beginning of the Younger Dryas mini ice age. Most of the other sites, these black mat sites that have been found across 3 continents, either don't have such precise age depth models or don't have them at all. So let's have a look at the next paper published in 2014 by Bement et al. Okay, so this is it's a very nice paper, and this is their main result here, this table. Now, it's careful work, and what they were doing is that they were looking for nanodiamonds at just one black mat site, that's Bull Creek in Oklahoma, where nanodiamonds have previously been reported by the Comet Research Group. So their aim was to look at the entire 20,000 years of sediment deposition at this site, across this black mat site, to see if the nanodiamonds at the Younger Dryas boundary can be reproduced, and to see if there are other peaks in nanodiamonds at other times. So remember, Van Hussel et al. Had previously wanted to know whether the nanodiamonds only appeared at specific time horizons, or whether they could be found almost everywhere, so that they could rule out wildfires for their production, even though on strong physics grounds we don't expect wildfires to produce nanodiamonds anyway. In fact, I think it's impossible. So what they found was this. This is their tabulated data. It would have been nice to have seen this table plotted as a graph, but nevertheless it's quite clear. Essentially, they find 2 spikes in nanodiamonds. One at the base of the Younger Dryas black mat, so essentially in the same or very similar position to where the Comet Research Group found it. And they find another peak, strong peak, in modern times, or relatively modern times, so at most a few thousand years old. Now these dates here are uncalibrated radiocarbon dates, so this is really nice for comparison with other sites. Okay, so if you look at this column, there are just 2 large peaks, a relatively modern one and one at the base of the Younger Dryas black mat. So it's clear that the Younger Dryas nanodiamonds at Bull Creek, at the black mat there, have been confirmed. There are also small amounts of nanodiamonds elsewhere, and possibly, or probably, these are generated by the background rain of cosmic dust that falls all the time. And the lack of other clear spikes shows they're not produced by wildfires as we expect. However, the modern spike here, less than 3,000 years old, it's intriguing. It suggests another cosmic impact, or maybe a volcanic eruption, has occurred in the last 3,000 years. We cannot know which of those cases it is without further analysis of the sediment. And note that another cosmic impact, probably much smaller, is not unexpected according to the theory of coherent catastrophism. Now the next paper, slightly later in 2014, is by Andronikov et al. So they analyze sediments from the bottom of a lake in western Russia. Here's their map. This is where their lake is found. This is the area of this graph in western Russia. And so they analyze the lake sediment at the bottom of this lake, and they find, so here is their data here. This is their model of the stratigraphy showing different types of sediment at different levels in the lake. And this is their data for heavy metal. So they measured the heavy metal content of the sediment at various depths going down into the sediment at the bottom of the lake. And so they analyze, they test for quite a few different heavy metals. We've got platinum here, nickel, copper, chromium, ruthenium, iridium, and so on. And so they find, again, this platinum spike, along with an abundance of some of the other heavy metals. Now, this signal here is not so strong as the one we see in the Greenland ice, but it is still pretty clear. Now the question is, does it correspond to the same impact event? Is it the same platinum signal that is found in the Greenland ice? Well, we know the Greenland platinum spike is located is isolated, I should say, by at least 100 years forwards or backwards in time. Let's just show you that plot. Okay, here we go. This is the platinum spike in the Greenland ice, and it's basically isolated in time by at least 100 years in each direction. And we also know that this spike occurred around about 10,940 BC, and I've done the conversion from this scale here. According to the GISP-2 ice core, okay, these measurements by Peteyev et al. Were from the GISP-2 ice core. So let's go back to the Andronikov paper. Now the authors suggest that this level in the lake sediments here corresponds to 10,650 BC. But this date is obtained from the GRIP ice core, not the GISP-2 ice core. Now we know that these two ice cores are misaligned by about 200 years at this time. We know that because of this paper in the journal Nature. If you look at the data in this paper, it shows that these two ice cores are misaligned by about 200 years. So actually this date of 12,650 kiloyears, or 10,650 BC, when we convert to the GISP-2 age scale, is about 10,850 BC. So we've got one level in the lake here which is thought to be 10,850 BC, and if this is the Younger Dryas platinum spike, then this spike would correspond to 10,940 BC. So a gap of around 100 years between here and here. So is that reasonable? Well, as I said, we know that there are no other platinum spikes within 100 years of the Younger Dryas spike in the Greenland ice. So probably this probably is the same platinum signal, or it's platinum from the same event. We also see, if we look at the stratigraphy, that this event here corresponds to this level in the lake, 590 centimeters, where we see an abrupt change in the stratigraphy from what is predominantly a silty layer here to a clay layer up here. And that's essentially what we'd expect at the Younger Dryas boundary. We'd expect changes in the stratigraphy. So everything's pointing towards this being the Younger Dryas, this spike representing the Younger Dryas impact event. In fact, Andronikov et al. Make the same conclusion in their text. They agree this is probably the same platinum signal as the one in the Greenland ice. So what they've labeled here as the pre-YD event should probably really be labeled as a VYD event. Okay, so it appears that the Greenland platinum signal has now been confirmed by an independent research group, Andronikov et al. However, the signal is fairly weak here. It's not nearly as strong as the one in the Greenland ice, and it would be nice to have a proper age depth model through these lake sediments to be sure that this is indeed the same event. Okay, so finally for this video, let's look at the next paper from 2014. So the authors here include Meltzer and Holliday, who have been highly critical of the Younger Dryas impact theory in their earlier papers. Now here, they are critical of the dating of all the geochemical evidence for the Younger Dryas impact at all the different black mat sites tested. So we've seen this problem brought up before. Remember in the last video where I reviewed the paper by Van Hussel et al. So they brought up the same issue. So these guys have the same concerns, but these guys are suggesting that the situation is even worse than Van Hussel thought it was. So according to their analysis, and we'll just scroll down. So this sort of flowchart describes their conclusions. So according to their analysis, there are only 3 black mat sites that are well dated to the onset of the Younger Dryas period, and they are Daisy Cave and Sheridan Cave, and also Big Eddy. Those 3 sites, all of them in North America. All the other sites, they claim, have problems with their dating. Okay, well that's slightly different to what Van Hussel et al. Was saying. So if we go to the Van Hussel paper and just compare with what they were saying, this was the main plot from there, or one of the main plots from their paper. So if you look at this plot, we find that about 7 or 8 of the sites seem to be well dated. So we have Daisy Cave, yes, that was in relatively good agreement, and Sheridan Cave was as well. But Big Eddy, which Meltzer et al. Think is okay, does not appear on this plot. So I don't know why. Perhaps that was overlooked. Anyway, the point is that Geldrop Astelahut, Murray Springs, Abu Huraira, Taliga, and Wally's Beach, which all seem to be fine according to Van Hussel et al., apparently are not good according to Meltzer et al. So we need to understand why it is they are questioning these sites like Murray Springs and Taliga, Abu Huraira, and so on. So if we scroll down a bit further, we find what it is that they are saying. So this is essentially a table of their main findings. So these are some of the sites that they are questioning. These are the dates that have been suggested by or reported by the Comet Research Group. And these are the dates that they find, Meltzer et al., according to their own analysis from the same data for the Younger Dryas boundary layers at these black mat sites. So when you look at the difference between what these guys find and what the Comet Research Group was suggesting, the difference is in this column, and as you can see, the differences can be a few hundred years, many hundred years in some cases. This looks to be a problem for the Comet Research Group. It means that the ages that they claim for the Younger Dryas boundary at these various black mat sites looks to be wrong, very wrong sometimes. Or does it? Hang on, there are no error bars here. There are no uncertainties quoted here at all. Well, that's odd. I mean, any scientist knows that a measurement without an uncertainty or an error bar is meaningless. So essentially this whole table is meaningless. So what is it that these authors are trying to say with this table? Because it doesn't look to be saying anything. It's really not clear what the point of this data is. To find out, we're going to have to look into their analysis in even more detail, which is buried in the supplementary material of their paper, of course. So I'll just go and find that. So this is the supplementary data for their paper, and the sites are listed in chronological order, and Abu Huraira and Arlington Canyon are two of the ones that they have disputed that we thought were okay, or at least Van Hoosel et al. Thought would be okay. So let's see what it is that they are complaining about. Let's have a look at Abu Huraira first and then Arlington Canyon. Okay, so if you read through the text about Abu Huraira, they write a lot of stuff which probably has little bearing on the calculations for this particular age depth model. All the things that they mention are probably within the noise. So here is the data they actually use to make their calculations. So these are their age depth models. Now these two plots are actually identical, it's just the axes have been switched around. So let's just have a look at this one. This one I think is a little bit easier to understand. And as you can see, there's a lot of scatter or noise in the underlying data, which is why I said that the minor problems they identify in the text are probably within the noise. So, I mean, this all looks fine. They have made a good fit to this scattered data here. But bizarrely, they're claiming that this linear fit or this linear regression is inconsistent with the Younger Dryas impact date, which in calibrated years is around 12,800 to 12,900 BP. So what are they actually claiming here? Let's be clear what they've done. So they take the estimated age of the Younger Dryas event, say 12,800 BP, and then they read off from their linear regression or their fitted line an exact depth in the sediment at Abu Huraira, in this case, according to their fitted line. And then they compare this depth that they find with the depth of the Younger Dryas boundary claimed by the Comet Research Group. And they find a difference. They find that these apparently are inconsistent. But this is crazy because everyone knows that this line itself is itself uncertain. Okay, this line is just the best fit. It's not the only good fit. In other words, there's a lot of uncertainty in the position and slope of this fitted line. So really this line should be drawn as a thick band which includes the uncertainty. But they haven't done that here. They just have this thin line and then they read off a single depth in the sediment according to the claimed age of the Younger Dryas boundary. In fact, I can hardly believe that they have done this. I can hardly believe that they are taking the exact depth from reading off this line without taking into account the uncertainty in this line. Now, we wouldn't accept this kind of data analysis from our undergraduates. And these guys are meant to be accomplished scientists. It's really embarrassing for them. So to be clear, their own age depth model that they have drawn here, or they have estimated here, shows that the radiocarbon data for the black mat at Abu Huraira is perfectly consistent with the estimated age of the Younger Dryas impact event, and it's completely false to claim otherwise. Oh well, that's Abu Huraira. Maybe they made a better job of analyzing the data from Arlington Canyon. That's the next site on our list. But do you know what? They didn't. They made exactly the same mistakes for that site as for Abu Huraira. Essentially, it seems that these authors, they're struggling with the whole concept of uncertainty in measurements. Now, as we saw before in the previous video, on average, the Arlington Canyon radiocarbon dates are generally too old by about 100 years or so. Okay, so on average they're around 13,100 just from looking at this data, whereas we expect the Younger Dryas impact age to be somewhere up here. But there's a lot of scatter in this data, which previously was explained in terms of the old wood effect. But as you might expect, Meltzer et al. Don't like that explanation. But the arguments they give against it in their text don't make any sense. For example, they seem to be suggesting in their text that the radiocarbon dates should all be too old by the same amount rather than being a lot of scatter in the data, which is what you'd expect from a forest. I mean, the wood in an old forest is going to have a wide range of dates, some of it old, some of it young. In fact, their discussion of Arlington Canyon in their text up here has the tone more of a rant than a scientific piece of writing. They don't seem to have anything to say that would significantly change the results of this analysis. If they just focused on the data and their analysis, once again, they should conclude that the old wood effect is a perfectly reasonable explanation for this data. Now, I'm not going to go through every case for you, but believe me, they have made exactly the same mistake for every site they've analyzed. They have forgotten to include the uncertainty in their age depth model from every site. It's hard to believe they can have done this. It's so bad. In fact, I think we can just bin this paper. So let's just delete it from our bibliography. It's really bad science, and it should never have been published. In fact, it should be withdrawn. Actually, there seems to be a trend here. We keep finding that the opponents of the Younger Dryas impact theory are just not very good at data analysis. And really, I mean, incompetent in some cases, like this one. And it's a real shame because their papers seem to have been quite influential in the research community, which I suppose says a lot about this research community too. Okay, so that's enough for this video. To sum up, more evidence has been found or confirmed in favour of the impact theory in terms of a nano-diamond signal at Bull Creek and a platinum signal in a Russian lake sediments. And given that all this geochemical evidence has now been confirmed by independent research groups and it looks solid, opponents of the Younger Dryas impact theory have taken as a last resort to questioning the dating of this evidence, suggesting that the data does not support a single event across these continents. And although they do have a point in that proper dating of many of the sites is either absent or not accurate enough to be convincing, it seems there are enough sites with good quality accurate dates across the three continents to carry the impact theory, which is what we would expect given the excellent timing of the platinum spike in the Greenland ice with the onset of the Younger Dryas climate change. Okay, so if you liked that, then please take a look at my book and my blog, and I will review the final papers from 2014 in the next video, which will follow in a couple of weeks.